Namaste student. In this video I am going to explain the remaining properties of the periodic table. In the previous video I already explained atomic radius or atomic size, how it varies in the periodic table, that is in the down the group and along the period. Now the next property, it is called as ionization enthalpy. Okay, now what is the meaning of ionization enthalpy? This concept is very important. Usually definitely question will be asked in the final examination, so you should understand properly. Okay, now what is the meaning of ionization enthalpy? Ionization enthalpy means it is nothing but a amount of energy. This is the energy I have written as E. Amount of energy is required to remove the electron from the outermost shell. Amount of energy is required. The word required is very important. I will tell you why it is. Okay, the amount of energy is required to remove the electron from the outermost shell. Okay, now the example I will take as lithium. Lithium as atomic number is 3. Electronic configuration is 1s2, 2s1. Okay, so I will draw the structure also. Two shells I have to draw. First shell it contains 1s2 electron. Second shell it contains 1 electron. Okay, after lithium, down the group I will consider sodium. Down the group, okay, sodium atomic number 11, so it is 1s2, 2s2, 2p, 6, 3s1. So here I will draw the shell number. Okay, so first shell it contains 1s2, second shell it contains 2s2, 2p, 6, that is 8 electron is present, and third shell it contains 3s1. Okay, now what is the meaning of ionization enthalpy? Now here if I want to remove the electron from the outermost shell, so I have to apply various amount of energy to remove the outermost electron. Okay, now in this case this shell is very close to the nucleus. Okay, in this shell the second shell is very close to the nucleus compared to the third shell. So since second shell is very close to the nucleus, so what happened, the electron, nucleus tightly hold the outermost electron. Okay, ಗಟ್ಟಿಯಾಗಿ ಹಿಡಿದಿಟ್ಟುಕೊಂಡಿರುತ್ತದೆ. ನ್ಯೂಕ್ಲಿಯಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು, outermost electron ಅನ್ನು ಗಟ್ಟಿಯಾಗಿ ಹಿಡಿದಿಟ್ಟುಕೊಂಡಿರುತ್ತದೆ. Okay, and this in the second example what I have given as a sodium. Here what happened, compared to the first one, the distance third shell, it is little far from the nucleus, so holding capacity it becomes weak. Okay, compared to the first example. So what happened, since it is tightly, this electron is tightly held by the nucleus, I have to apply a large amount of energy to remove the outermost electron of this second shell. But in this case I have to apply the less amount of energy is required to remove the outermost electron in this. Okay, now if I take example as a potassium, next down the group 19. So what is the electronic configuration? You will get 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So if I draw the structure, this is the nucleus. Okay, so four shell have to draw. Okay, this is 1s2, 2 electrons are present in the first shell, 8 electron present in the second shell, even third shell also it contains 8 electrons, and last shell it contains 1 electron. Now here fourth shell is again little far from the nucleus, so holding capacity, ಹಿಡಿದಿಟ್ಟುಕೊಳ್ಳುವ ಸಾಮರ್ಥ್ಯ ಕಡಿಮೆ ಆಗ್ತದೆ. ಯಾವುದ್ರದ್ದು? ನ್ಯೂಕ್ಲಿಯಸ್. ಇದು ದೂರ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಾಗೆ ಅದನ್ನು ಸ್ಟ್ರಾಂಗ್ ಆಗಿ ಹಿಡಿದಿಟ್ಟುಕೊಳ್ಳುವ ಸಾಮರ್ಥ್ಯ, ಕೆಪಾಸಿಟಿ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಸೊ ಇಟ್ ವಿಲ್ loosely held by the nucleus. That is, electron which is present in the fourth shell will be loosely held by the nucleus. Okay, so what happened compared to this? So if I want to remove the electron which is from the outermost shell as a fourth shell, for me a little amount of energy is sufficient, because it is not tightly held, it is loosely held by the nucleus. So comparatively, if I move from lithium, sodium, potassium, here in the first case I have to apply more amount of energy because it is tightly held by the nucleus. Okay, in the case of sodium, not more, compared to lithium it is less is enough, but in the case of potassium, what happened, still less amount of energy is required to remove the electron. Okay, imagine that I have two set of stones. Okay, one is a big stone, another one is a small stone. Imagine if you want to lift the small stone, less amount of energy is enough to remove the small stone. If you apply same amount of energy to lift the big stone, it is not possible. So what you will do, you will put a high amount of energy to remove the bigger stone. So that is the meaning of ionization enthalpy. Here we are using energy to remove the electron from the outermost shell. Okay, so what is the meaning of ionization enthalpy? That's why a required word is very important. Okay, amount of energy is required. ಯಾವುದಕ್ಕೆ ಎನರ್ಜಿ ಬೇಕು, ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ. ಎಲ್ಲಿಂದ? ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ ಇಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ರಿಮೂವ್ ಮಾಡಬೇಕಾದ್ರೆ ನಮಗೆ ಎಂತ ಬೇಕು? ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಈಸ್ ರಿಕ್ವೈರ್ಡ್. ಓಕೆ, ಸೊ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಇಸ್ ರಿಕ್ವೈರ್ಡ್ ಟು ರಿಮೂವ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ರಮ್ ದ ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ionization enthalpy. Now, how it varies? Okay, so I hope you understood the definition of ionization enthalpy. This part I will erase. Now, how it varies down the group. Okay, how it varies down the group. Now down the group example I already explained here. So down the group, now lithium, sodium, potassium, rubidium, cesium. Down the group, what happened? Atomic sizes increases. Okay, so first I will write the points so that you can understand what happened. You can say, okay, say the final answer. Now atomic size or atomic radius is increases. Atomic size increases. Okay, increases. Now, so what happened to the effective nuclear charge? Effective nuclear charge is effective nuclear charge means it is nothing but a holding capacity of the nucleus. Okay, or attraction power of the nucleus. So effective nuclear charge is decreases. Effective nuclear charge is decreases because as distance increases. Okay, so what happened? The amount of required energy to remove, if I want to remove electron from the 2s shell, I have to apply more amount of energy. Here 3s little less, here still more less. If I go next to rubidium, because it is a fifth shell, so still more less. So what happened? Ionization enthalpy is ionization enthalpy is decreases down the group. Ionization enthalpy is decreases down the group. Okay, so a question will be asked like this: define ionization enthalpy. How does it varies down the group? So define ionization enthalpy carries 1 marks. How does it varies down the group? It carries 2 marks. That is, down the group ionization enthalpy decreases. You have to write the reason. What is the reason? Down the group atomic sizes increases. It is understood because atomic number is increases, principal shell is increases, and atomic sizes increases. In that one word only it will come all the information. So only the point is enough as atomic sizes increases down the group. So effective nuclear charges decreases. Now you have to write the conclusion with respect to ionization enthalpy. What is the conclusion you should supposed to write? As we move from top to bottom, like this. Okay, rubidium, cesium and francium like this. As we move from top to bottom, okay, it is easy to remove the electron from the outermost shell. It is easy to remove the electron from the outermost shell. So less amount of energy is required to remove the outermost electron from the outermost shell as we move down from top to bottom. Okay, so this is a conclusion word. I will repeat conclusion word. So what is a conclusion word you should write? Since atomic sizes increases, effective nuclear charges decreases, so it is easy to remove the electron from the outermost shell as we move down from lithium to francium as we move down from lithium to francium. So that's why ionization enthalpy decreases down the group. I hope you understood the concept of ionization enthalpy with respect to down the group. Now I am going to explain along the period. What happened along the period. Okay, now how does ionization enthalpy varies along the period? How does ionization enthalpy varies along the period? Okay, so along the period I have considered as a second period lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Atomic number I have written 3, 4, 5, 6, 7, 8, 9, 10. Okay, so electron configuration. So 2s, 1s2, 2s1. Here 1s2, 2s2. This is a 1s2, 2s2, 2p1. This is for this 1s2, 2s2, 2p2. For this 1s2, 2s2, 2p3. So like that it will go. Okay. So neon, what is the electronic configuration? Neon is 1s2, 2s2, 2p6. Okay. So this is the last electronic configuration in this second period. Okay. Now here what happened from lithium to neon, it contains only 2 shells. Only 2 shells. Shell number will not increase. But here what happened to the outermost shell, electrons are added. More and more number of electrons are added. So here outermost shell contains only 1 electron. In the case of beryllium, outermost electron contains 2 electron. In the case of boron, outermost shell contains 3 electron. In the case of carbon, outermost shell contain here 4 electron. In the case of nitrogen, outermost shell contains 5 electron. In the case of oxygen, outermost shell contains 6 electron. In the case of fluorine, okay, so like that. So finally, for the neon, outermost shell contains how many electrons? 2s2, 2p6. So 8 electrons. Like that it will go. Okay. Now here what happened? Electrons are added to the same shell. So electron density increases in the same second shell. So effective nuclear charges increases. Because of this reason, effective nuclear charges increases. Okay. Since effective nuclear charges increases, I already told in the atomic radius, outermost shell it experience inward pull. Nucleus power ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಾಗ ಏನಾಗ್ತದೆ ಅಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯಸ್ outermost shell ಅನ್ನು ಒಳಗೆ ಎಳಿಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತದೆ. So outermost shell experience inward pull. So based on this thing, now I can write the points. What and all points I can write? That is along the period what happened. Okay. Now along the period, ionization enthalpy increases. Ionization enthalpy increases. Now what is the reason? Now here what happened? Since electrons are added to the along the period, electrons are added to the same shell. Electrons are added to the same shell. Okay, so what happened? Effective nuclear charge. Okay, effective nuclear charge is increases. Here you can write or atomic size is decreases. Okay, atomic size is decreases. This point also you can write. Okay, or you can write electrons are added to the same shell. So effective nuclear charges increases. So what happened? Effective nuclear charges increases means the nucleus as we move from lithium to neon, nucleus holds the electron tightly. ಲಿಥಿಯಂ ಇಂದ ನಿಯಾನ್ ಕಡೆಗೆ ಹೋಗುವಾಗ ಏನಾಗ್ತದೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಸ್ಟ್ರಾಂಗ್ ಆಗಿ ಹಿಡಿದುಕೊಳ್ತಾ ಹೋಗ್ತದೆ. ಓಕೆ, ಸೊ in the case of lithium, in the second shell only 1 electron is present. So okay, so less amount of energy is enough to remove. But in the case of beryllium, 2 electrons are present. So you have to remove 2 electrons. So compared to lithium, you have to apply little more amount of energy. Okay. In the case of boron, how many electrons are present in the outermost shell? That is 1s2 2s2, 2p1. So in the outermost shell it contains 3 electrons. Now number of electrons is increased, isn't it? So applying amount of energy is also more. Okay, so neon, in the neon last, it is atomic number is 10. Neon atomic number is 10. So it contains 1s2, 2s2, 2p6. So in the last shell, how many electrons are present? 8 electrons are present. So to remove 8 electrons, you have to apply high amount of energy. So from the beginning, lithium, it contains only 1 electron in the outermost shell. So little amount of energy is sufficient. But as we move from lithium to neon, number of electrons are more and more in the outermost shell. So more and more amount of energy is required to remove the electron from the outermost shell. So based on that, ionization enthalpy is increases along the period. Okay, ionization enthalpy increases along the period. Okay, so this is the reason. I hope you understood. So remember the concept. Ionization enthalpy is a compulsory question for the exam. It is asked for 3 marks or 2 marks. What is ionization enthalpy? How does it varies down the group? Or what is ionization enthalpy? How does it varies along the period? It is asked for 3 marks. So how to answer the question? First, what is an ionization enthalpy? Write the definition. Next, how does it varies down the group? First, you have to write ionization energy decreases down the group. Then reasoning part you should write. Same thing, how does it varies along the period? If suppose question is asked, ionization enthalpy increases along the period. And then you have to write the reasoning. Reasoning, it is written here only. Electron are added to the same shell. Okay, in the along the period. So effective nuclear charges increases. So it is very difficult to so more and more amount of energy is required to remove the outermost electron as we move from lithium to neon. So this is the answer. I hope you understood the concept. Okay, the next concept is electron gain enthalpy. That is the next third property. First property, atomic size or atomic radius. Second property of the periodic table I explained, that is ionization enthalpy. Now this is a third property, electron gain enthalpy. This is also a very important question. So electron gain enthalpy. What is the definition of electron gain enthalpy? It is nothing but amount of energy is released. See, I underlined. Okay, in the previous case ionization enthalpy, for the required I underlined. Here amount of energy is released when electrons are added to the outermost shell. Now you can remember like this, ionization enthalpy, that is with respect to cation, because electrons are removed. In the cation, electrons are removed. Okay, electron gain enthalpy, amount of energy is released when electron is added. Usually electrons are added in the concept of anion concept. Okay, so chlorine, how many electrons are present? 17 electron, atomic number is 17. So based on that I will write the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p5. Okay, 2, 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 5, 17. So 17 electrons have distributed like this. Okay, now chlorine has a capacity to accept 1 electron because of see, outermost shell accepting and removal of electron based on the it is done based on the octet rule. Octet rule means after removal or after adding, outermost shell should contain how many electrons? 8 electrons. So this is called as a octet rule. Now here I can't remove. Okay, if I add, it is immediately it attain a octet rule. Okay, so that's why. So outermost shell contain 7 electrons. So if I add, how many it becomes? 8 electron in the outermost shell. So that's why if I add 1 electron to the 3p5, so it becomes 3s2, 3p6. So this chlorine becomes a Cl minus, chloride anion. This is a anion. Okay, anion, negative sign. So how anion is formed? By the addition of electrons to the outermost shell. How cation is formed? By the removal of electron from the outermost shell. Okay, now in the case of sodium, 11 electron. So 1s2, 2s2, 2p 6, 3s, 1. Now here I can't add. Okay, the best one, if I remove this electron, what happened? You will get attain a octet structure. Outermost shell contains a octet. Okay, that is in the sodium cation. Okay, so what is the rule of removing and adding the electron? You should remove either you should remove electron or add electron in such a way that after removing or adding, outermost shell should contain how many electrons? 8 electrons. This is called as an octet rule. So based on that, here I am going to add the electron. Okay, so while adding, here how many electron is added? 1 electron is added. So chlorine becomes a chloride. Okay, so while adding, what happens? Some amount of energy is released. While adding, some amount of energy is released. If you want to remove the electron, what you should do? You have to apply the amount of energy. Energy is required to remove the electron from the outermost shell. But here, while adding the electron, energy will be released. Energy will be released. Okay, so that is called as a electron gain enthalpy. That's why word I underlined. In the case of ionization enthalpy, amount of energy is required. That word is very important. In the case of electron gain enthalpy, amount of energy is released when electron is added to the outermost shell. Okay, that you should write properly. So this is a definition of electron gain enthalpy. I hope you understood the concept. Definition of electron gain enthalpy. Now, how it varies? How it varies in the periodic table. So in the periodic table means I will consider as a down the group. Okay, down the group. So electron gain enthalpy. I will write like this: electron gain enthalpy, EGA. Electron gain enthalpy. Okay, short form I will write. Now down the group, what happened? I will take one example. Down the group: lithium, sodium, potassium, rubidium, cesium, francium. Rubidium, cesium, francium. Okay, but I will write only for this 3 electron, 11. This is 19 atomic number. Okay, so based on that I will write 1s2, 2s1. Here 1s2, 2s2, 2p6, 3s1. Here 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, here how many circle I should draw? That is 2. Okay, outermost shell contains 1 electron, 2s1. Here how many circle I should draw? It is 3 circles. Here how many circles I should draw? 4 circles, because 4th shells are present. Okay, 4s1. This is 3s1. This is with respect to lithium, this is with respect to sodium, this is with respect to potassium. Now what happened? Now electron gain enthalpy. Now here, since this shell, second shell is very close to the nucleus, attraction power is more. Okay, here what happened? Nucleus is little far from the outermost shell. Nucleus is still little far from the outermost shell. So attraction power of the nucleus, it becomes less and less. So if attraction power is more, what happened? More and more electron will be added. ಒಂದು ವೇಳೆ attraction power ಜಾಸ್ತಿ ಇದ್ರೆ more and more electron are added. Okay, so here what happened? Since the nucleus is very close to the outermost shell, so attraction power is more, so immediately electron will add. Immediately electron will be added. Here electron will add, but it will take time. Here still it is lower time. Electron will add, but still it is in a lesser capacity. So here, since it is immediately added, what happened? More amount of energy will be released. Here, compared to this, less energy amount of energy will be released. Here, still more less amount of energy will be released. So what happened? Amount of energy is releasing from lithium to francium. It is decreasing. It is decreasing. Here very close to the nucleus, so attraction power is more. Immediately it will attract to the outermost shell. Electron is immediately attract or added to the outermost shell. But nucleus, it is little far from the third shell. Okay, so it will attract, but not immediately. So slowly it will attract. So less amount of energy will be released. Here still it is slowly attract, because distance is more. Okay, so what happened? Immediately, not immediately, it will attract, it will take time, so still less amount of energy will be released. Okay, so based on this concept, what and all point I can write? Electron gain enthalpy is decreases down the group. So even ionization enthalpy is also decreases down the group. Electron gain enthalpy is also decreases down the group. So see, remember the concept. Ionization enthalpy is also decreases down the group. Electron gain enthalpy is also decreases down the group. But reasoning is also same. Okay, so what happened down the group? Atomic size is increases. Okay, atomic size is increases. Since atomic sizes increases, what happened to the effective nuclear charge? That is attraction power of the nucleus. Effective nuclear charges decreases. Effective nuclear charges decreases. See, even in the case of ionization enthalpy also same reasoning I have written. Only conclusion part is different. Okay, so electron gain enthalpy, what you should supposed to write the conclusion. So what happened as we move from lithium to cesium? Since attraction power is here decreases, okay, effective nuclear charges decreases, addition capacity is also decreases, so less amount of energy will be released as we move from lithium to cesium, okay. So actually only 2 points is sufficient if you write in the exam. Okay, no need of writing the conclusion, this is enough. But you should know how to conclude the points. Since effective nuclear charges decreases, what happened? Lesser number of electron will be added to the outermost shell, so less amount of energy will be removed from lithium to cesium. Okay, so this is a concept about down the group. Now we'll move to the along the period. Okay, along the period. Now here, so electron gain enthalpy. What happened? Same concept is repeated. Ionization enthalpy down along the period, it is increases. So here also increases. Okay, increases along the period. Now why? Now lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then neon. 3, 4, 5, 6, 7, 8, 9, 10. This is atomic number. So 1s2, 2s1, here 2s2, only outermost shell I will write. Okay, so 2s2, 2p1, 2s2, 2p2. So here what? 2s2, 2p 6. Now here what happened? More and more electrons are added. Okay, so first point, electrons are added to the same shell. So what happened to the effective nuclear charge? Effective nuclear charge. What happened? Effective nuclear charge is more and more electrons are present on the outermost shell. So increases. So what happened? Since effective nuclear charge is more, or nuclear attracting power is more and more electrons will be added. More and more electrons will be added to the outermost shell. So what happened? Effective nuclear charge is electron gain enthalpy is increases. Only 2 points is sufficient. Electrons are added to the same shell. Effective nuclear charge is increases. So electron gain enthalpy is increases. For all the concept like ionization enthalpy, electron gain enthalpy, down the group it is decreases. Reason is also same. Electron gain enthalpy, down the group it is decreases. Reason is also same. Same thing along the period, it is increases. Both ionization enthalpy as well as electron gain enthalpy. Reason is also same. Okay, so one part if you study, you can answer 2 concepts. Okay, so I hope you understood the concept of electron gain enthalpy. Yes, the next property is electronegativity. Okay, now what is the meaning of electronegativity? Electronegativity means it is nothing but a definition I will define first. Capacity of an atom to attract a shared pair of electrons towards itself. Capacity of an atom to attract a shared pair of electrons towards itself. Now here I have written one example. Now I will explain example with the hydrogen fluoride molecule. Hydrogen fluoride molecule. Okay. First I will write how molecule is formed. Hydrogen fluoride, how this molecule is formed. Now hydrogen, atomic number is 1. So electronic configuration I have written 1 is 1. Now hydrogen has 1 electron. Hydrogen has 1 electron here in the outermost shell. So this is electron I have written here. Now fluorine, 9 atomic number is 9. 1s2, 2s2, 2p5. Now outermost shell, I will write box form structure. 2 electron in the 2s orbital, and according to Hund's rule you have to you have to fill the electron. So 1, 2, 3, 4, 5. So that means here it is a paired, here it is also paired, here it is also paired, but this is unpaired. Okay. Now same thing I will put it in a dotted structure. Okay, dotted structure. This is called as a Lewis dot structure. Okay, anyway, that I am going to explain in the next chapter. But you just see that this one arrow means 1 electron. This is N, another arrow, that means 1 more electron. So this is paired. Same thing, 1, 2. This is also paired. 1, 2. This is also paired. This is only 1 electron is present, single electron. Now, so unpaired electrons will combine. Okay, like this. Unpaired electrons will combine. Okay, 1 single electron of hydrogen and 1 single electron of fluorine combine each other to form a bond. Okay, to form a bond. Now, so each end contains an electron. Each end of line contains an electron. This is a concept. Okay. Now, what happened here? Now, fluorine, it is a electronegative atom. Fluorine is an electronegative atom. So, fluorine is an electronegative atom. What is the meaning of that? It is a capacity of an atom to attract a shared pair of electrons towards itself. Now here what happened? Fluorine is more stronger than the hydrogen. Fluorine atom is more powerful than the hydrogen atom. Okay, it is like a tug of war game. So few people are standing at the one end of the rope, few people are standing at the another end of the rope. Both are pulling the rope. Okay, so like that. Okay, if suppose A team is very strong, what happened? A team will pull the B team, like that. Okay, so same way, same concept I am applying here also. Okay, you know the tug of war game. In Kannada we are saying that hagga jaggata. Okay, ಒಂದು ಟೀಮ್ ನವರು ಸ್ಟ್ರಾಂಗ್ ಇದ್ರೆ ಆ ಟೀಮ್ ನವರು ಇನ್ನೊಂದು ಟೀಮ್ ಅವರನ್ನು ತನ್ನ ಟೀಮ್ ನೆಡೆಗೆ ಎಳಿತಾರೆ. Okay, like that, same thing. Okay, so here fluorine has a strong attraction power. So what happened? See, imagine that I have given a place for this. This is a place for hydrogen atom. This is a place for hydrogen atom, like tug of war. Okay, so fluorine, what happened? It tried to attract the hydrogen's electron. Fluorine ಏನು ಮಾಡ್ತದೆ, ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಎಳಿಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಿದೆ. ಬಟ್ ಸ್ಟಿಲ್ ಹೈಡ್ರೋಜನ್ ಇಸ್ ಆಲ್ಸೋ ನಾಟ್ ಲೀವಿಂಗ್. Okay, hydrogen is also not leaving. Hydrogen, but what happened? I already told that fluorine is a very powerful element. So what happened? Automatically hydrogen's electron, it will come here. It will come here, not entirely shift to this place. It will come here, displaced. Okay, so based on that, okay, why it will come here? Because this is an electronegative atom. This is a electronegative atom. So what is the meaning of electronegative atom? It is nothing but the capacity of this element, capacity of an atom to attract a shared pair of electrons. Now this is a shared pair of electron. Okay, electron is a shared. This is a shared pair of electrons towards itself. So this is called as a electronegativity. Okay, I hope you understood the concept of electronegativity. So it is nothing but a capacity of an, while recalling the definition, you just imagine the tug of war game. It is nothing but a capacity of an atom to attract a shared pair of electrons towards itself. Okay, so this is about the definition of electronegativity. Now what happened to the variation of electronegativity down the group and along the parent. Now we'll see down the group. Concept will be same. electronegativity I will write En. It is a decreases down the group. Okay, ionization enthalpy is also decreases down the group. Electron gain enthalpy is also decreases down the group. Electronegativity is also decreases down the group. Now concept remains same. Lithium, sodium and potassium. I already told that. Here how many shells are present? Only 2 shells. Here it is 3 shells. Here it is 4 shells. Okay, so 4 shells. Now here what happened? Distance is increases. So what is the point I can write? Atomic size is increases. Atomic size is increases. Now what happened to the effective nuclear charge? As the distance is increases, effective nuclear charge is decreases. This is fixed for all the concept. Effective nuclear charge is decreases. Okay, effective nuclear charge is decreases. So what happened? Effective nuclear charge is decreases means it is nothing but attraction power. So negativity, electronegativity means what? I can call it as a attraction. So attraction is decreases down the group. Okay, attraction itself it is decreases down the group. So I'm just correlating with the electronegativity. Since atomic size is increases, effective nuclear charge is decreases. What is the meaning of effective nuclear charge? It is nothing but attraction. Okay, so electronegativity means what? It is also attraction. So attraction means decreases, or electronegativity is decreases down the group. Only 2 points is sufficient. Okay, and then along the period. Along the period what happened? So concept will be repeated. Along the period, effective nuclear electronegativity is increases. Along the period it is increases. Why? 1. Here electrons are added to the concept is repeated. Electrons are added to the same shell. Okay, electrons are added to the same shell. So what happened to the effective nuclear charge? Effective nuclear charges increases. Effective nuclear charge. All this concept I explained. Okay, so effective nuclear charges increases. So effective nuclear charge means it is nothing but a attraction power. Electronegativity means it is also called as attraction power. So since effective nuclear charges increases, electronegativity is also increases. So this is called as a electronegativity, concept of electronegativity. So all the atomic radius, ionization enthalpy, electron gain enthalpy and electronegativity, it is 4 properties of the periodic table. It is there in the syllabus. So I explained all the 4 properties. Okay, now I am going to explain nomenclature of element. Okay, now nomenclature of elements with atomic number greater than 100. Usually this is asked for 1 marks, but it is a compulsory question. Easily you can score. Okay, if you understand the concept. Now, what is the meaning of nomenclature? Nomenclature means it is nothing but a naming of elements. Okay, naming of elements. Now here naming of elements with the atomic number greater than 100. Actually, what happened after 100? Few elements were not discovered properly. Okay, not characterized, even though discovered, but it is not characterized properly, or properties are not studied. So what the scientists decided that until the discovery of such elements is proved, its name is officially recognized based on the systematic nomenclature, like this. Okay, so they have given one rule, that is they have given one rule as a digit 0 to 9. Okay, so name is given. 0 means it is nil, 1 means un, 2 means bi, 3 means tri, 4 means quad, 5 means pent, 6 means hex, 7 means sept, 8 means oct, 9 means in. It is already given in the notes. Okay, so please check it once. And the notes, I think somewhere I made a mistake. So please check. So I will repeat it again. 0, nil, 1, un, 2 means bi, 3 means tri, tri, 4 means quad, quad, 5 means pent, pent, 6 means hex, hex, 7 means sept, EPT. 8 means octa, 9 means in. Okay, so this is the name you should recall. Okay, and then once naming is finished, at the end you should write IUM. Okay, I will tell you how to write. This is a concept you should remember. Now 101, if you want to write the name of this, okay, IUPAC nomenclature for this element, how you should write. Now 1 means, what is that? 1 means according to the name list it is UN. So I will write UN. Since it is a first letter, you have to write a capital letter U. Okay, so UN. 0 means it is nil. I will connect nil, NIL. 1 means again UN. Now I finished. Okay, so at the end what you should add IUM. So this is a nomenclature part. UN, nil, UN, IUM. Okay, actually after after once the properties of element having atomic number 101 it is discovered, finally it is named as Mendelevium. Mendeleev name only it is given, Mendelevium. Okay, but the nomenclature is written as like this. So same thing I will write it for 102. Okay, now 1 means what you should write again, UN. Since it is the first letter, you should be written capital letter UN. What is a 0? Nil, NIL. 2 means by. I finished writing. Finally what you should write, add at the end IUM. Okay, like this. Now here, since I2 to I are there, so only one I is enough. So only one I is enough. So UM I will connect. Okay. So if you want to write for 115, how you will write? 1 means it is again UN. Again 1 UN. 5 means pent. Okay, so at the end what you should add like this. Okay, if you want to write about 120, 1 means UN, 2 means BI, 0 means again nil, NIL. Then finally you have to add IUM. So this is a nomenclature. Okay, I hope you understood this concept. Now I will give a few homework about the nomenclature. Write it and send through WhatsApp. Okay, so it is 116 as example, 118, 111, 124. Okay, so write this. Write IUPAC nomenclature of 116, 118, 111, 124. Okay, so based on this system, write a nomenclature of this element and send me through WhatsApp. So by this I finished chapter 3 called, that is periodic table, classification of periodic table and its properties. It is easy to learn. So important questions I already given in the form of PDF. So refer that. Try to compare the answers. It is given in the notes also. So buy it. Keep it ready for the final examination. Thank you.